Hi, this is Dave Lipscomb. I'm going to try and make sense of sets and some basic concepts of sets that can be confusing. Sets are so easy to really understand the basics of, but there's a couple tricky things where sets can have the null set in them or not in them, or how many elements are in a set that has the null set, and what is a power set, and all this little notation with epsilons and sigmas, and just kind of all this crazy little, math symbols that seem to make math hard. But if we understand just what the symbols are trying to say, it can be so easy to just understand the concept of a set and not get confused in all the terminology. So let's see what we can do here as I try and explain and break down the basics of sets. Okay, here we go. Let's try and explain sets. So let's start off. What is a set? A set is basically just a group of stuff. I mean, it's really any group. So, but typically in math, we talk about in math, it's often numbers. So, for example, a group could be in the way we talk about sets is we draw a bracket and then we talk about the things in the set and separate it by commas. So 1, 2, 3, that's a set. It has, 3 things, and the things are 1, 2, and 3, right? We could also talk about, a set with, this has infinite things. And this is what you call, this would be, these would be like counting numbers. Okay, so let's see. So one key thing is that sets are not ordered. Sets are not ordered. So the set 3, 2, 1 is the same as the set 1, 2, 3. And you can talk about equals. Sets can be equal. Again, they're not order. Now, the final thing about a set, when we're just sticking with the very basic stuff, we talk about subsets and proper subsets. And a proper subset is denoted like this, and a subset is denoted like this. And they're almost the same. These are almost the same, except a subset can also be equal. What do I mean by that? So if A is equal to this set, then 1, 2, 3, the subset A is also a subset of A, right? So A is a subset of A. And you can kind of think of this thing as, it's kind of like a proper, it could be, a proper subset or equal to. And that's kind of like the, less than or equal to, greater than or equal to. You can kind of think of this as like a subset or equal to. So for example, a proper subset 1, 2 is a proper subset of A, or of 1, 2, 3. But 1, 2, 3 is not. And this symbol slash means it's not a proper subset of 1, 2, 3. Right? Because it's equal to. A proper subset, the in, okay, another key thing, right, let me say it one other way. A proper subset always has fewer elements than the set. Okay, so that's kind of the basics of a set. Let's just stop there and absorb that. Sets are groups of things. They're not ordered. And then there's lots of subsets of a set. Oh, and another key point. Well, let's not get into the null set yet. Let's not do that yet. So there's lots of subsets of A. You know, 1 is a subset of A, 1 comma 2 is a subset of A, 2 comma 3, you know, 1 comma 3, you know, 3. All of those are subsets of A. Okay. Now let's talk about, and we'll do a few more examples here below maybe, and then we'll talk about maybe here we'll talk about, you know, A equals 1, 2, 3, and then B equals 3 comma 4 for purposes of these examples. Okay, so elements. So E, this means is an element of. That's easy. So just forget about this notation, and this is what A is. A is just 3 things. You know, this is A. It's a set of 1, 2, 3, and then we just draw it with using these bracket symbols. But A has 3 things in it. It's a circle with just 3 numbers. And then B, likewise, is a set with 2 numbers. Well, let's just kind of put this 4 a little further away so it doesn't look like the number 34. So it has 2 things, and A has 3 things. So now we can just look at this and say, well, yeah, what is an element of A? Like when you say 1 is an element of A, 2 is an element of A, right? There's only 3 elements in A. If I said is this, you know, you can get into some tricky things. Is 1 comma 2 an element of A? The answer is no. No, this is not an element of A. These are the elements of A, the numbers 1, 2, and 3. There's no sets that are elements of A. We'll get into some of that trickiness in a little bit here. You know, so what is a subset of A? A subset of A is any set that I can pull these elements from. So I'm going to make subsets of A. So I can pull from here, I can pull 1, 2, or 3 things down and make a subset. So I could make this. That is a subset of A. So let's call this thing, you know, C. So this is set C. C equals 1 comma 2. Right? So C is a subset of A, and C is also a proper subset of A because it has less elements than A. Remember? So if, though, I chose for C to be 1, 2, and 3, then C would be a subset of A, but C would not be a proper subset of A because it has the same, because C has the same number of elements as A. Now let's bring in the notation for the number of elements. So the number of elements of C equals 3, and the number of elements of A equals 3. And so C, remember, a proper set always has fewer elements than the set. So in this case, because C has 3 elements and A has 3 elements, it is not a proper subset when you pull in all 3 elements. I guess we didn't need to use example B here, but well, maybe we can make one more example. So is the set 2, 3, 4, we ask the question, is that a subset of B? Well, 2, 3, and 4 is in B, but 2 is not. So 2, 3, 4 is not a proper subset of B, and it's also not a subset of B because the element 2 is not in B. So hopefully that starts to make sense. All right, now let's talk a little bit about the empty set, which starts to get confusing. Just a sec. We may have to end up moving some things down. But the empty set gets a little bit confusing because it's basically a set with no elements. So the empty set is equal to this thing, which is the same thing as if I just had, the empty set is just a big group of, there's nothing in here. And the n of the empty set equals 0. The n of the empty set is 0. There are no elements. Okay, that seems easy enough. If something can have an infinite number of objects inside it, then something can also have no elements inside it. That's called the empty set. Now, the interesting thing, there's a couple interesting properties. And these things you just got to kind of noodle on and just take on faith. So, one, the empty set is a subset of any set. So that's right. So if I look at A, B, and C up above, for example, the empty set is a subset of A. If I go all the way back up to this A, the empty set is also a proper subset of A because it has, remember, it's got fewer elements than A, right? The n of that equals 0. The n of the empty set is 0, and the n of A equals 3. So because it's a subset of A and it's got fewer elements, it's also a proper subset of A. Okay, this is just something you're going to have to kind of remember. Well, let's just talk about, we'll just leave it there for a second. We're not going to go into any other interesting properties. Well, just remember that one. That's going to be the key one for right now. Now, there's this other thing called the universal set. So whenever I'm talking about something, the universal set is all possible numbers, or all possible elements in the, quote, universe of my discussion. Okay, so here, let's just kind of do this. This will help block things out so that you don't get confused. So if we're talking about, so let's just say, for example, we're talking about, all numbers between 0 and 26. So that's like, so that's 1, 2, 3, ... 25, right? It's all numbers that are bigger than 0 and smaller than 26. So this is that's my universe. So then A could be 1, comma 2, comma 3, and B could equal 5, comma 10, comma 15. Here, let's extend this a little bit, comma 4, comma 5. Those would both be, so we'd have, then in this case, we'd have the number of elements in the universe equals 25, the number of elements in A equals 5, and the number of elements of B equals 3. That makes sense? Okay, let's talk about two other things real quick. This is called, I'm going to have to move some of this down. We're just going to get rid of it. To talk about, this is a union, and this is intersection. So the union means, you know, kind of like all elements of both, and then kind of remove the duplicates. And the intersection is just kind of the duplicates. Right? So let's look at that. So union, and that's written like this. A union B. So then we write 1, 2, 3, 4, 5, because it's everything that's in both. So everything that's in A, remember A is 1, 2, 3, 4, 5. This is A. And B is 5, 10, and 15. So B is 5, but 5 is already in the thing. 10 is not, and 15. Okay? Now A intersects B. It's like the intersection. It's like, what's the same? Well, 1 isn't the same. 2 isn't the same. 3 isn't the same. 4 isn't. So only 5 is in both of them. Okay? So that's intersection and union. Now, if C is equal to 20, so this is C, this is B, and that's A. A intersects C, there's nothing there. So that is the empty set. Right, if that's C, and that's B, and that's A. Okay? So unions and intersections, pretty straightforward. Now power sets are kind of interesting. Power sets are simply, let me move power sets. We're going to move this down. Is basically the set of all subsets. Okay, so let's look at that for a second. So if I have 1 and 2, if A, then the power set of A is equal to, well, so now I'm going to build all the subsets. So I can take a 1 and a 2, and remember I can always have the empty set. So the power set of A is equal to all 4 of those things. It's each one of those. And so the power set is always a set of sets. So we have the empty set, the set that contains 1, the set that contains 2, and the set that contains 1 and 2. Right? So the power set is always a set of sets. Right? So there's 1 set, 2 sets, 3 sets, 4 sets. So the power set does not have elements that are the elements, like numbers, whoops, this is a little bit confusing. That's what I meant to say, right? This is, that's the fourth set. Okay, so let's do this. If A is equal, let's just say it's equal to this letter C, because it doesn't always have to be numbers. So if A is equal to C, I always like to kind of draw it with the circles. So then the subsets are the thing that has the C in it and also the thing that has nothing in it. So that the power set of A is equal to the empty set and the set C. Now the interesting thing is that the power set, this is really cool. And so the power set of a set is always equal to 2 to the number of elements in the set. Oh wow, this looks, but this is actually easy. So all this is saying is that, the number of elements in the power set is equal to 2 to the number of elements in the set. So in other words, let me just say that differently. The number of elements in the power set of A is equal to equal to 2 to the power of the number of elements in A. Still sounds confusing, but let's make this simple. Okay, let me just move this over here, and then let's explain this in purple. Okay, A has 2 elements. So 2 to the 2 equals 4. So the power, the number of elements in the power set equals 4, right? A has 2 elements, so the power set of A has 4 elements. Likewise, in this case, A has 1 element. So the power set must have 2 to the 1, or 2 elements. Right? Now if B has 3 elements, then the power set of B has 2 to the 3 equals 8 elements. Right? So all I'm saying is that a power set of a set of 0 has 1. If this is the set, the n of the set, then the n of the power of the set equals 1. If it's 1, then it has 2 elements in the power set. If it has 2 elements, there's 4 in the power set. 3, there's 8. If there's 4, there's 16. That's all this is saying. The set, the number of set elements, in the power set. Okay, let's stop there, and then I'll make another video with the examples.